In this next example, we're going to have to, as in example 1, square twice. So we've got a square root inside of a square root equaling an isolated square root. Let's square both sides right away. It's going to cancel the outer square root on the left-hand side, and we have no more square root on the right-hand side. Subtract the 21 so that the other single square root remaining is almost isolated. And as in example 1, since it's multiplication, we can still go ahead and square both sides. Now, -4, squaring that, -4 times -4 is positive 16. Squaring the square root of x is just going to give us x. On the right-hand side, I'm going to use the special formula that you could find by multiplying a minus b, that quantity, times itself. Previously, I had referred to the quantity a plus b being squared. All that's happening by switching plus b to minus b is that here we could have been thinking of plus a negative b, and so plus 2a times negative b will give us minus 2ab. So x squared minus 2x times 21 plus 21 squared . 2 times 21 is 42, and 21 squared is 441. Subtract 16x from both sides. And we've got x squared plus minus 58x plus 441 is equal to 0. Well, let's see here. Since the 441 is positive, we need two numbers of the same sign, but they have to add up to -58, so they have to be both negative. So the very first option is -1 times -441. That gives us a sum of -442, which is way too big. Since it's not even, we can't divide by 2. I can divide by 3, though. Let's see here. I believe that's going to be -47. -147, which will give us a sum of -150. Still too big, but getting closer to that -58. Since we couldn't divide by 2, don't try to divide by any other evens. It doesn't end in 0 or 5. So how about 7? 7 times -63, which gives us sum of -70. We're getting closer. Let's try 9. Since 3 would go in, 9 might. And I think -49 will do the job. Double checking on my calculator here real quick. It works. And that gives us the sum of -58 we desired. So we've got x minus 9. That quantity times the quantity x minus 49 equaling 0. Set each factor equal to 0. And we'll find that x is either 9 or x is equal to 49. our original equation, square root of 21 minus 4 square root of x, is that equal to the square root of x? Square root of 9 is 3, so we've got 21 minus 12